Good day, folks. This is Amir McKean coming to you from AICpublications.com with another edition of the Black Stemporium. This is the aspect of where we engage with the engineering aspects and the technological advancements for you, for your child, for your mentee, for any type of career that you're looking for in electrical engineering. And in order to do that, we're going to start off with the basic building blocks. So today we're going to go over just how to light a room with two different brightness levels. And with what we're doing here is we're going to go over how the technology is today and from what it came from in its original state. All right. So, as engineers, one of the main things that we do all the time is we do what we used to do as children. We explore, we pick up things, we look at things, and we try to ask ourselves, how does this work? What does this say? What does this mean when this does this or that does this? All right. One of the fundamental things that we have all done as kids is we played around with blocks, whether it was stacking blocks, just exploring the blocks, feeling and touching the blocks to explain and understand the different textures and the things that we could gain from our touch, our feel, our sense of smell, our sight, and everything else that we were using in our sensory perception. So today, I want to take you through what is the basic fundamental building blocks of all engineering, and that's the block diagram. All right. I want to take you through this right now and let you see what we're controlling right now in lighting different intensities. We're going to have a different block. The first block is going to be the power control block. The second is going to be the power switch. The third block is going to be the current and the voltage overload control. And then the fifth block is the light intensity control. The fifth block is what we always start off with, what we want to do. So this is the end of what our design is supposed to be. So what you see in green is what we want. What you see that comes before it is how we get to what we want. Now, one of the things that a lot of people seem to have problems with, especially when they're in high school or even the undergraduate courses in college, is understanding what in the world does the math have to do with all this stuff. We like the technical stuff, we like the cool gadgetry and the wizardry and all of that, but why in the world do I always have to worry about so much of the math? Well, what we're doing here with AIC Publications and this uh, program that we have with the Black Stemporium is we want to demystify the math for you. So we're going to give you the basic understanding of what is needed in terms of the math for all the applications that we give you. Now, the reason why the math is important is because the math tells us how we can control each single block. So even though we look at a design with our bare hands, we look at it, we examine it with our perceptions and our ability to understand and our five different senses, it's what we gain from that five different senses that allows us to determine what kind of blocks we need. But it's the math that tells us how we can control, how we can manipulate, how we can change the functionality of each of those single blocks down to an exact methodology, which can ultimately give us the outcome that we need in the block that's green. Now, in this particular circuit, when we're talking about lighting two different places with two different brightness levels, this is the first block that we have. We're coming off with a 9-volt battery source. We're putting that into a switch. We're connecting that 9-volt battery into a switch because if we don't do that, then the battery source will always constantly be on, and you're always going to have to change the battery because it's going to run out of power. It's going to run out of current. It's just going to be looping all the time and it's going to be on. It's like leaving a light on that never turns off. After a while, after that light has been left on, you're going to have to replace that bulb over and over and over again. And then your cost of replacing the bulbs unnecessarily is going to go up. That's why we put switches on the lights, so on and so forth. You have them on the walls, you have them whether they are talk, whether they're smart sensors, you have switches to control for that particular purpose. The third block that you're seeing is very important. It's the current and voltage overload control. What this does, it ensures that whatever goes on in the circuit, if we end up getting a bolt of lightning, if somebody comes and replaces the battery with another battery that's too big or too small or whatever, it makes sure that the circuit that comes behind, meaning to the right of that resistor that you see there, that 10K ohms resistor, whatever comes behind that will be protected from an overflow or a surge of too much current. So anytime that we build any type of device, anytime that we build any type of circuitry, we always want to put in protections that are going to protect it from being overloaded with current or having an overload of voltage. All right. What you see to the right of that, which is the LM7805, is simply a 5-volt voltage regulator. What that means is whatever current that we put into that regulator, it will give us a steady 5-volt current of supply to the right side of it, to the outside of it. All right. And what you're seeing there under that last box, which is the light intensity control, that's what we want to control. That's what we're interested in. So you see that 5 volts source coming off at the right of that 7805 voltage regulator. And what we're going to do is we're going to have the second resistor that's going to be an extremely bright light. And you're going to have this third resistor, which is going to be a dimmer light. The reason why we are able to control that, remember now we go back to being able to control the blocks with the math, is that we understand what's a basic principle called Ohm's law, which basically states that in a circuit branch similar to this, just like this, that the current going through any type of object is equal to the voltage that's divided by the resistance that it's going through. So through this, we're able to control the exact brightness. And same application, same mathematical formula for this as well. So now when we go to that particular circuit, I'm going to share my other camera for you right now and show you what happens when we turn that on. Now, this is actually the circuit in its application that you're looking at right now. And I'm going to flip on the batteries. And as you can see, the one to the left is literally 5 times as bright as the circuit on the right. So this leads us into the next, which lets us know, what does the math say? This is actually very, very important in terms of what the math says, because the math talks to us. Yes, I said that. The math actually talks to us. We have to be able to understand what the math says. Now, the math, as I said before, lets you know what Ohm's law states. Current is equal to the voltage divided by the resistance in a particular circuit branch. So in that first light that you saw, in that first light emitting diode, we had a 201 ohm resistor in the path, which meant we had 25 milliamps going through that first LED. In the second resistor, in the second resistor branch that you saw, the second LED, which was dimmer, we had a higher resistor value, which was 1000 ohms. So we had 5 times greater of a brightness in the resistor to the left than we did to the right. So the math here literally tells us that the higher the current that we can control that goes through a circuit, that goes through a light emitting diode or any type of candle or lamp that we're going to put there, the brighter the light can be, the greater the intensity can be. And it tells us also that we can control any particular element of any electronic circuit that we want, just if we listen to the math. Now, the current and the future applications of this. As I said to you before, this is an older circuit, and you can find these types of circuits in houses. You can find them in buildings. You can find them in commercial buildings. You can find them existing in your table lamp that you use to give light to your desk, or you use to give light to whatever book that you might be reading late at night. You can also interface this with a computer and therefore completely eliminate the use of having to physically toggle a switch up on a wall. However, a lot of people are thinking now with AI or artificial intelligence that it can do away with a lot of these hardware applications with the light on the wall. Now, not necessarily, because the artificial intelligence is based on these types of designs. So the engineers who are designing the artificial intelligence are designing them with these types of circuits in mind. So if you understand the basic fundamental building blocks, you understand what the math is saying to you, and be able to talk the mathematical language, you can control each of these single blocks down to a finite level to get whatever guaranteed outcome that you want to get. All right. Hope you've enjoyed this. Like us on this channel that you're watching. Go to aicpublications.com. You can join our email newsletter list. You can get your free ebook PDF books that highlight a lot of the 10-minute STEM engineer program that we have going forward. All right. Till next time, we'll talk to you later. And as always, those of us in the AIC Publications family, we want you to attain the knowledge, innovate for success, command your future.